Here we are. We are again in the year with our fresh webinar for this year. And this time we're going to kick off with a very interesting topic, which is around the geolocation data and how it's measured. So today I have with me Oliver Gasser, the head of research from IPinfo. Hey, Oliver.
Hey, Vincentas, great to be here. Yeah, super excited to be part of this IPXO webinar series. And yeah, thanks a lot, Vincentas, for the invitation.
Thanks a lot. Thanks a lot for accepting our invitation. And you know, I wanted always to unfold, you know, all those mysteries, how actually, you know, you guys do with geolocation data, what are the data sets, usage type, and all that. And I'm sure that many other attendees of this webinar are very curious, learning more about you guys do those impressive measurements. And you know, I'm a really big fan of what you do, and I think today we're going to extract more of your things and what we should kind of see and apply in reality using your data. So perhaps I can give you to start your presentation, and then we can go slide by slide, unfolding the actual things what surrounds the geolocation data.
Yeah, that sounds awesome. And yeah, as I said, super excited to be here. And I think this is an interesting topic. I have a kind of academic background. So for me, I started using IP geolocation during my research at TU Munich and also then at the Max Planck Institute for Informatics in Germany. And there it was more like I was using it, but I was, I thought, okay, IP geolocation, not that complicated, right? You know, just mapping an IP address to a location. What could there be complicated about it? But then once I joined IPinfo almost 2 years ago now as head of research, I began to understood all of the complexities and all of the edge cases that came with IP geolocation and IP data in general, not just limited to geolocation. So I just wanted to get started with a very simple, or the basic idea of IP geolocation and how IP geolocation datasets are built. So as I said, the basic concept of IP geolocation is to map an IP address to a geographical location. And that's usually done with geolocation hints. And the geolocation hint could be, anything on can be on different granularity. So it could be on a country level, or maybe even a state level. It could be at the city level, or even at the data center level. It's just collecting all of these hints for specific IP addresses or IP prefixes. And the goal there is to collect as many hints as possible, and then kind of merge those hints and aggregate them and try to figure out which ones make sense.
Yeah, so what exactly means hints? Are those type of signals where you kind of get and correlate the patterns? Can you expand on this a little?
Yeah, so that's a perfect segue to the next slide. So this is kind of a list of possible geolocation hints. So one possibility is geofeeds. Geofeeds is a standardized IETF standardized format. It's basically a CSV file. You can see an example here on the right side of the slide, where you have an IP prefix with geolocation information attached to it. So, for example, this is the geofeed file published by the IETF itself. The IETF has three meetings per year. They use the same network for those meetings, so they kind of bring it with them. So they always need to update their geolocation information, so that when people using the IETF network for example, in Singapore here in November 2019, they would be seen as somebody visiting a website from Singapore and not from the previous IETF.
Yeah, and just to clarify, IETF is the sort of, I should say, working group as such that actually creates the internet standards.
That's correct. Yeah, IETF is the Internet Engineering Task Force, and they are responsible for creating internet standards. There are various different working groups within the IETF, which discuss and have a kind of a consensus way of, or a way to find consensus about those standards, to move the internet forward, to adapt new protocols, to say what should or should not be done with respect to technicalities.
How heavily IETF is involved in developing the standards around the geolocation and location itself for the IETF?
That's a great question. There is, so the geofeeds format and also other, so geofeeds format is an RFC, so an internet standard, has been standardized within the ops area working group, so the operations area working group. And there are also various other standards which tell you, for example, that you should be looking at WHOIS attributes to find those geofeeds. Because geofeed is just a CSV file, and then you obviously need to make the link from the prefix to the CSV file published.
Connecting the dots,
URLs.
basically.
Connecting the dots. That's I guess one area of where geolocation is present within the IETF. Another area which happened relatively recently was the Internet Architecture Board, which is also part of the IETF. Which organized an IP geolocation workshop in December of last year, so last month, where different stakeholders came together and discussed, okay, what's the current state of IP geolocation, what works well, what should be improved. And for example, there was a lot of discussion also about geofeeds and some of the challenges around geofeeds, incorrect data in geofeeds, parsing issues, all of these kinds of peculiarities when it comes to geofeeds. And yeah, so as I said, there are a bunch of different hints. So the first one I've already mentioned, these are the geofeeds. There, you can also derive hints from WHOIS entries themselves, who will publish country level information, or sometimes also in the comments there is even more fine granular information in there. You can look at reverse DNS pointer records, which might encode, for example, airport codes. So when you run a trace route, and when you look at the path that the packet is taking, you sometimes see those like 3 or 4 letter codes in the domain name along the path, where you could then map those 3, 4 these letter codes to airports which are closely located to a specific.
I noticed actually that you're trying to map also the airport IP addresses. Yeah, it's smart.
That's true.
A question from like well, trace routes, they all it's pretty clear, but how do you get the device data? So for example, if you do the trace route, you not necessarily can get because the packet is not going from the device, or you can kind of get those packets from the end destination. How that works?
Yeah, so we do have our own IPinfo app where we can get device data from, and we also do have collaborations with third parties so that we can get device data from them, and that then allows us to kind of combine those different geolocation hints into kind of a hint mapping engine, which then aggregates everything and removes maybe hints that we do not trust. Because one of the issues here is that some of those hints are kind of they are published by the network operators themselves, right? So in general, we can trust network operators. They have good intentions in general, but sometimes there is an incentive to lie about geolocation, right? So if you think about the VPN use case or the proxy use cases, where people have an incentive to kind of fake the geolocation, right?
Especially with those virtual locations within the VPN industry, it's like
that is true. That is true. I have a couple of things about that as well, so we can happy to talk about virtual locations as well. Right, and that's basically the geolocation, kind of an overview of the geolocation hints. And then the next step is to kind of rank and also validate those geolocation hints. And the way that this is done is due to using latency measurements.
So
we
triangulation in the so just to kind of enlighten a little bit our audience, I'm sure you do the triangulation as well. So what actually Oliver is saying that IPinfo runs a different latency checks, basically the trace routes and pings, where you can measure the milliseconds by the distance of where the actual IP address is.
Right, that is completely right. So we run different types of measurements, and from those measurements, we can then understand, okay, how long did it take for a packet to go to the destination and back? That's what's called the round trip time. So how long did it take for this round trip? And using speed of light constraints, because we know that a packet or anything cannot go faster than the speed of light. And in fiber, the speed of light is even, or the maximum speed is even less than the speed of light. It's usually 2/3 of the speed of light. So we know that it can travel 200,000 kilometers per second, right? And using that mapping from the duration that it took for this packet, applying then the speed of light constraint, we can then validate certain locations and say, okay, these other locations, they are theoretically impossible. Like the laws of physics tell us, okay, it's not possible for this geolocation hint to be accurate. And that's kind of the nice thing about these validation of the geolocation hints, that we have kind of proof that this location cannot be accurate, whereas we can say, okay, this other location is a possible location one.
So talking about it's very interesting. Now you're actually showing how many POPs you have, etc. But I would like to step a little bit about the actual internet providers. So what do you observe? We in my previous webinars, we spoke about the internet penetration. We spoke about the new locations, the rural areas, and whatnot. What do you observe? How many new ISPs are established? Within, let's say, last year.
That's a good question. So what we can definitely see is an increase in autonomous systems, and autonomous system is more than just internet service provider. So it's also education networks. It's a kind of large companies, content delivery networks, and so on. So the number of autonomous systems is definitely growing, and it obviously depends a lot on the country of how many ISPs you find by country. And in some countries, there is little growth in the number of ISPs because it's kind of a consolidated market already. But there are certain countries, for example, in Brazil or so, where you have hundreds of ISPs, where you see growth in the number of a lot of small ISPs also. But then in other European countries, there's more of a consolidation going on, where you have like large ISPs and not that many new ISPs entering the market. But overall, the number of networks, the number of autonomous systems is still increasing.
It's overall increasing, but it's not increasing so significantly, because actually I checked yesterday Kaida's IS rank, and I spotted around nearly 78,500 ISMs.
Yeah, that is correct. And so it's not a kind of exponential growth. It's more like a slow linear growth. But it's still increasing. So yeah, that's something that we see also in our data, that there are constantly new networks, constantly new ASs, autonomous systems coming online. We also do have these kind of very peculiar ASs where they're run by a single person, like personal or person ASs, which is something that we've been looking into as well. So yeah, there are some very interesting edge cases where you don't have the large ISPs or so, but somebody is running like a hobby project and just has an ASN for themselves.
Yeah. So let's take 180 degrees now angle. So ISPs are well known, they are well established, the networks are known as well, where they operate. But how do you actually measure the anycast? Because there are systems where actually they basically fly the packets to the nearest destination. Based
That's correct.
Based actually on your geolocation.
That is true. That is true. Some anycast operators do use our geolocation data to determine, to also steer traffic in a sense.
But the other way around.
Yes.
For example.
Yes. So we do enumerate, or we can detect anycast using our Probenet measurements. So we do have a network of more than 1,300 points of presence.
I got it.
And that allows us then to also not only do like the latency measurements that I spoke about earlier, but also to detect anycast deployments. And in addition to detecting those anycast deployments, we can also enumerate the anycast instances. So how many anycast instances and where are they located, right? Because again, using the latency measurements from the Probenet, we can then determine, okay, there are like 15 anycast instances, 5 in North America, 4 in Southern America, and then a couple in Europe, and a couple in Asia and Africa as well. So that kind of network of probes and these kind of large-scale measurements that we're running allows us to do that.
Right. I will let you carry on, please.
Yeah. Right. Yes. So as I've said already, so we do have the Probenet, which is a global network to conduct measurements. We have currently more than 1,300 points of presence globally, covering more than 140 countries and more than 540 cities. We're continuously expanding the Probenet. We are also reaching out to different kind of stakeholders, also to universities, academia, also to IXPs, to data center operators, obviously also to hosting providers. So we try to have like a very good mix in our Probenet, and we have dedicated people just working on expanding the probe network. So that's something that we're really proud of, and we take a great passion in improving it, maintaining it, and just making it better, because it helps us do our job, and it also then makes the data better, which then makes people using the data happy. And just as a kind of one data point, so half of the autonomous systems, so half of the networks, are reachable within 1.3 milliseconds using the Probenet measurements, which is kind of a really, really low latency that you can have for those latency measurements. And yeah, we use the Probenet for the evidence-based measurements and data verification. We do run a bunch of different measurements, such as pings, trace routes. We run port scans and many more measurements. And we are also present, as you can already try understand from the numbers of the 540 cities. We try also to be present in very niche regions to ensure a comprehensive coverage. And just to kind of name a couple of, let's say, more exotic regions, we're present in Malawi, in Iceland, on the Isle of Man, in Guam, and also in Mauritius. And we're constantly adding new points of presence to kind of increase the coverage even more of our probe network.
So how your kind of typical Probenet looks like?
So the typical probe that we have in the Probenet is a very simple server or virtual machine that we set up with our own custom measurement software, and then we run the measurements there continuously, and we collect all the data from those measurements, and that then allows us to get kind of a broad view of internet latency, but also other characteristics such as open ports and what have you, whatever you can collect. Also paths using trace routes.
So talking about RIPE Atlas and Kaida's Probenet as well, comparing those to yours, how flexible they are.
So we love RIPE Atlas, and they are doing a great job. Kind of have a very good coverage. Their coverage is still very much focused on, I would say, Europe and North America, but they're really doing a good job of also covering the other regions of the world. And we're using RIPE Atlas ourselves, so running measurements there as well. And the benefit of our own Probenet is that we can run any measurements that we would like, right? So RIPE Atlas in that sense is a bit more limited. You have I think like 5 different types of measurements that you can run. You can like ping, trace route, DNS measurements, TLS measurements maybe, and HTTP measurements. So the number or the type of measurements that you can run in RIPE Atlas is limited, right? Whereas with our Probenet, we can run any measurements that we find interesting or that is useful for our data pipeline. And what that allows us to do is, if we find some new interesting type of measurement, we see some great research that is being published, or we do research ourselves in the research team, we then are able to deploy this on a large scale on all of those POPs in the Probenet directly.
So can you guide me how the actual geolocation data structure looks like? I know there is a country, there's city. What other type of data sets are within the geolocation information?
Right. So we have country level, or obviously we have continent level geolocation. Country level, we have region, which is sometimes relevant if you think about different states in the United States, for example. And then we also have city level information, and then we also assign a confidence or an accuracy radius for those fields as well. Yes.
So you see, my next question to you would be how accurate your database is, because we actually had a very interesting case with one of the geolocation databases, and it's actually was pretty awkward situation, when we had the /24 announced in Frankfurt. But we were rejecting to update that geolocation because we were saying that /25 is in London and the other /25 is in Brussels. And we said, this is impossible. So we said, well, it's impossible to actually announce less than /25, 24, We said, well, we see that it's the same network. Okay, then we asked them, can you explain why do we see /30 in France and /28 in Berlin from the same subnet in your geolocation database, So we could not explain this, but again, how often you get those discrepancies in geolocation, but be honest, because nobody is accurate, that.
So I would say it like this. So geolocation is a moving target, right? So you have to constantly be innovating and improving to kind of even keep the accuracy they're currently at, or further improve it, right? So it's not as trivial as when I joined IPinfo, I thought, okay, how long can it take to solve the geolocation problem? Maybe like 2 more years or so, and then everything is done. We can go home and do something else. So that's not how it works, because there are a lot of different things that are changing in the internet, as you know, right? So the internet is constantly evolving. So you have to constantly innovate to keep track and outpace the competitors. Regarding the accuracy question, so there are, I guess, two main ways to look at accuracy. One of the things that we do is we have a set of ground truth IP addresses that we compare against, and that we also then don't use in our geolocation pipeline, because otherwise it would kind of screw up the whole accuracy, because then we would be 100% accurate. So that's one part of it, or one way of looking at accuracy, and that kind of motivates us to constantly improve, right? If we see, okay, there is a certain area that we still need to improve, that's where we'll put our focus on. The second part is customers or prospects themselves, right? So they have an interest in accuracy, obviously, as well. And what they usually have is they have a subset of IP addresses where they know the true location from some, either from their own insights, or from somewhere else. And then they do the accuracy comparison internally, right? So they we provide them the data, and then they do the accuracy comparison, maybe compare us, our IPinfo to competition and so on. And we're doing very well in those scenarios. And the Probenet is just one of the reasons why we're doing very well. But one example that I can maybe share is a large CDN recently did a comparison between us and other geolocation database providers, and we came out on top with I think like 85% city level accuracy, and the others like 67 or so. So there is like a big margin between.
Congrats on that.
Thank you.
So to stay on the top of a game, you obviously need to update and monitor everything. And I remember you were up there too. You remember in Madrid, an internet measurement conference, many internet researchers are very proud, if they, scan the big portion of IPv6, it's like a big milestone for them,
Yeah.
But we'll talk about IPv6 later on. Let's stick to IPv4 for now. But, talking about the actual updates and how frequent they should be, like from the user perspectives and from general use, you guys are the fastest one on updating and applying the changes, the corrections. But others, even update once a month. Is it like, not so bad or good having such a large update frequencies? And how do you think the frequencies should be handled? Perhaps it should be real time.
So that's a great question, and as you say, the update frequency is an important one, because it gives you the most up-to-date information when you need it, right? And we do run, or we do publish updates daily. So we have two basic modes of how to get our data, either through a database download, and there are the update frequencies every day. And if you're using our API, it will be basically instant, right? So if you're using our API, you will get the most updated data freshly delivered to you. And with the database download, obviously, we can't generate database downloads in real time, but we do it every day, which then also provides a reasonable update frequency for our users. So it's basically a lot of it boils down to the users then themselves to either use our API so that they have the freshest data, or ensure that their database download is frequently updated. Right. So if they have like a script which is running every month or so, we might be providing updates daily, but if they just run the script every month, then that obviously makes it challenging to have the freshest data available, at the customer. But yeah, we try to be as fast as possible because I think this is also something that sets us apart from the field, from the competitors. And I think we're doing a very good job at that, and constantly trying to make that faster even more.
So let's talk more about VPNs, proxies, and perhaps some of the abusive methodologies, if I may.
Sure, you're the boss. All right, so IPinfo is more than a geolocation company. It's an internet data company. And one of the other big fields that IPinfo is present is VPNs, or anonymity datasets in general, or privacy datasets, if you want to call those. So basically, we do run multiple different measurements to detect VPNs. We cover hundreds of providers, and we are also validating the claims that the VPN providers make, because they are sometimes like claiming, okay, we have, I don't know, VPN exit nodes in 100, or maybe 200 servers, or 200 countries, sorry. So very, very large numbers, which are usually not really accurate. So, and one of the questions that we asked ourselves in a recent study is, should you or can you trust your VPN location or your VPN provider? And what we did in that study was we analyzed the VPN location claims. So, and for that we had 150,000 exit IPs across 137 possible exit IP countries. And we found that 17 out of the 20 providers that we analyzed had instances where traffic was exiting a different country than the country that the VPN provider claimed. And another interesting finding was that we identified 38 countries where basically there was no physical exit at all, but the VPN providers claimed to have them anyway, right?
So can you say that it's a marketing trick?
I would say it's very easy for VPN providers to just update their website, let's say every month or so, and just increase the number of countries by 3 or 4, right? Usually there is nobody checking this, right? So there's nobody who really validates the location. But we wanted to really see, are those location claims accurate? So I would say,
but you check those locations.
We did check those locations, right? And we found that not all of those claims were accurate. In fact, only 3 of the 20 providers that we analyzed, all of the locations we could validate.
Matched.
Yeah. And for example, here you can see a couple of the virtual only exit countries, right? So you alluded to this, a couple of minutes ago, the virtual location, right? So this is basically the VPN provider already admitting, okay, yeah, it's not a real location, but we do our best to kind of fake the location. So they're admitting that the exit server is not in that country, and you can clearly see that there are different regions where this is happening, and usually it's a kind of a mix of remote locations, let's say less developed locations from an internet perspective, right, or networking perspective. So it's very difficult or very costly to deploy a server there. The link bandwidth might not be as large as in some other countries. So it's very intriguing for those VPN companies to just say, okay, yeah, I have a server in Bahamas, but in fact it's just in the US.
But I was thinking about those virtual locations the other day, and it's kind of bad and good that we do that. If we, it's always good to analyze, why we do that, and I think that there is a demand for it. And
Yes.
the demand grows, in my opinion, from the environment, from the political environment, from the restrictions, that actually were put by the governments and whatnot. You have a very good example, for example, China, Italy, and democracy is also restricting the content. So, the things are actually, I think, will gonna be very mainstream in terms of that those virtual locations probably will need to be there. Even though they don't have the abilities to deploy servers up there, but perhaps for people who are exiled from country and need to access something local, virtual location actually works.
I guess it depends, I would say. So
of course it depends. It depends. Yes, absolutely.
If the user understands what the virtual location is, and understands what the consequences might be of using a virtual only exit IP addresses from a VPN provider, then sure, they're free to do so, and that's their right. But the problem is then if the virtual exit IP is in a country where or the actual exit IP is in a country where different laws apply, and then maybe law enforcement or somebody else will get their hands on the data that the user of the VPN wants to avoid, right? And that then is can get into serious trouble.
That's also a very interesting case, because it would be great to see some sort of statistics, and I don't know, perhaps some spam house or some other guys that actually do millions of those fingerprints, measure how many of those virtual locations cause the problems versus how in reality they're useful, for a good a goodwill things, that the end user wants to achieve.
Right. Yeah, and I think just maybe quickly, we need to distinguish between VPNs which have a actual exit node in a specific country, and then a virtual or a VPN which only has a virtual location somewhere. And what the second point means is that the VPN doesn't even have a server in that specific country, and it only claims so with the inaccurate information in geofeeds, or also in the WHOIS, right? And if a user of a VPN is using the first part, basically uses a VPN and then kind of tunnels to that specific country, then it's fine. It's fine from a technical perspective, because then they are in that specific country, and then they can the laws of that specific country apply. But if that would then happen in a virtual location, then they are not actually in that country, and different laws might apply. Different surveillance things might happen. So that's problematic, because the user doesn't actually know what is the exit IP country that I'm going through, right? It doesn't say, okay, the VPN providers usually don't say, okay, it's a virtual location and the actual location is this. They don't disclose that, right? They just, sometimes they say it's a virtual location. Sometimes they don't even mention that it's a virtual location, right? So those are then the very problematic cases that can arise. And maybe just showing, one of the examples that we found was actually in the Bahamas, where we found different VPN providers where they claimed, okay, it's the exit node IP, the VPN server is in the Bahamas, but we found, okay, I mean, that can't really be, because if we have like a sub-millisecond duration, round trip time from Miami or from New York, the Bahamas are relatively close to the US, but they're not that close.
50% US, Bahamas is.
I would say maybe 99% US. So yeah, I mean, the Bahamas are close, but what this tells you is, so 27 milliseconds means it's 27 kilometers away from Miami. That's not the Bahamas. Bahamas are not 27 kilometers away, right? And it's also not 42 kilometers away from New York, right?
Yeah.
So there's no way that's physically possible.
Yeah, yeah. Makes sense. Makes a lot of sense. So VPNs, we have this clear kind of misalignment with virtual locations, as I understand. This is like the biggest thing, right? I would like to step back a little and talk about very trendy thing that everyone talks about is the AI. AI is kind of, has also its, should I say downside? I wouldn't call downside, but a side effect that actually AI engines need to train their models to make them smarter. Now, what I actually see, even Cloudflare started to kind of exercise the model where we could monetize the content of their end users. But at the same time, I think that AI learning models will definitely need more and more information, more and more content and context at the same time. But, without scraping or without data mining, the whole web, it's, I think, impossible. How do you distinguish, let's say, I don't know, good, bad practices of those web scraping methods, and what surveillance or what kind of methodology do you apply on those?
Yeah, I think that's as you say, a very kind of trendy topic, AI in general, and it has it's a double-edged sword, right? So you don't want to give away your data for free to the AI, so that everybody can basically then use the AI and uses your data. On the other side, you want to be present somehow in those models, so that people then see, okay, if they ask the model, okay, what's the geolocation of this specific IP address, and they say, okay, using IPinfo, I determined that the geolocation is this and that. So that's a very fine balancing act that we have to do as a company to determine, okay, where does it make sense to be present in those models, but and what's the where do we draw the line? From a technical perspective, we are very much kind of following the philosophy of evidence-based data, right? So we internally, or in our data pipelines, we are making sure that the output of the data, the data that we give to our customers, is not kind of hallucinated, right? So we have the evidence, using all of our measurements that we run, and all of the data pipelines that we're consistently churning through, and that's the result is based on the evidence that we have. It's not based on something that some magic AI machine learning model is just made up and said, okay, here, this is the data that the customer might want or might need. So we're making really sure that everything that we are providing to our customers is based on real evidence that we can then show the customer and say, okay, this is why we made this determination of XYZ, right?
Yeah. Interesting. So what patterns do you see from that perspectives? I mean, I know that you have a usage type model, usage type tags, hosting, mobile, business, I think. Yeah. Can you explain a little about those usage type of things?
Right. So those are different tags that we assign either to IP
VPNs
addresses
as well, I think, right?
We do have a lot of information about VPNs as well in our privacy data set. So we, as I said, we're an internet data company. We try to provide as much useful data to people out there as we can, and we run a lot of measurements to kind of create or then input the results of those measurements in a data analysis pipeline, which then creates as an output those products. As you said, we do have different kind of tags, but also different products, such as the VPN or the privacy products, where we then are able to determine if an IP address is used as a VPN exit node, or even for same for residential proxies and for anonymity services such as Tor, the same thing as well. So all of these kinds of measurements that we're running make sure that we can have the most accurate data available and make that available to our customers.
Sounds good. And I think you want to carry on with your presentation.
I think that's basically the end of the presentation. So I can probably unshare.
So I'm interested to learn, who actually use your data?
That's a great question, and I think it's a very always when it's a great question, I would say it's a mixed bag, right? So it's different companies, but also just individuals using our data. We have IPinfo Lite, which can be used for free by anyone, which we've launched last year. Was very successful. But in general, I would say we have content delivery networks which use our data. We have service operators. We have ISPs. We have websites or big commercial platform providers. We have like small businesses, just hobby users which want to integrate our data into their hobby projects. So it's we have people from the ad industry, people from the financial sector. So it's a very broad portfolio of people using our data.
Interesting. So, I always was thinking, registries, they have those fields of the country, shouldn't be this within the expansion of registries where they should enrich the data, of IP addresses that they actually manage within their premises.
Right. So that's registries would say, no, we don't want to do that. That's what registries would say. At least that's my understanding, and that's what I've heard from registries talking about this. They don't want to be in the business of IP geolocation or any other internet data business. They are in the business of managing IP or internet resources in general, right? So they
registry.
Yeah. So that they don't want to be in the IP geolocation business. That's what they told me.
So talking about we touched on the structure of geolocation. We touched about VPNs, proxies, and whatnot. Yeah, let's talk about the fraud prevention, because I think that it's a very interesting topic to talk. And like, for example, I know that some of geolocations even have those fraud scores and whatnot, where they actually determine how likely you will get a fraud from that particular IP address.
Yeah.
What do you think about this? How accurate this information is, and can, let's say, users rely on it?
That's, I mean, so many good questions, Vincentas, I have to say. That's amazing. So we currently don't offer or don't provide any fraud data in that sense, right? And I think that's there's a big reason behind that, because we are an internet data company and not a security company. We do provide data which can be used by security companies to then ingest into their threat model, into their security pipeline, to then determine a fraud score or something like that. But my feeling with fraud scores is always it's usually like a number or a flag or something, and then it's difficult to interpret the flag. So from our perspective, it's best if we provide the data to our users and then let them decide, okay, is this enough for them to classify it as fraud, or maybe they want to have like an exception for something that is from a different country or so. And then usually it's not as simple like yes or no that the users want, right? They have a very specific use case in mind, and we do our best to tailor towards those use cases and provide the data to them so that they can then make the determination whether something should be classified as fraud or not.
Some controversial question where perhaps it could be a feature suggestion for you in your database.
Taking notes.
Very good. It's gonna be recorded, so save your time. We actually been thinking that since we are IP leasing, and network company, for us, it's also important to deliver the accurate geolocation information. And between, IPXO and IPinfo, we also have a geofeed and whatnot. But at the same time, we brainstorm a little that, for example, after the lease is finished, the IP address should be with no geolocation, because it's actually parked at some point, So it's basically like you rent a car and you rent a car, let's say for 2 weeks. That means that this is Oliver is driving that car. That means that this is a geolocation, But when you actually get to the rental company your car back, which you rented, it's again, with no geolocation, because it's nowhere, right? And we actually suggested a couple of times to a few of geolocations that you should actually treat the IP leased IPs that way. So the best, I should say, indication is, on which IS number they are parked. If it's on our IS number, that means they are parked, So it's about, it's a thing about trusting the different providers. And here I would say that 2025 and actually the last several years showed that internet definitely will gonna live with IPv4 for a long time. And in my view, that consolidation of the data from the different use cases is that source of truth, basically. The more data sets you would have, the better you would understand the geolocation. Prove me I'm wrong, please.
Okay, so that's now a very IP leasing specific question, which understandable. I was bound to come at some point during this webinar. So from a technical perspective, this is already possible using geofeeds, right? So if you don't have any geolocation information in a geofeed for a specific prefix, this means okay, there shouldn't be any geolocation attached to that prefix, right? So I guess the way to properly do this is once a prefix is added to the to IPXOs or some other leasing provider's platform, and it has not been used, or it's not been assigned to any of the people on the platform, then all of the fields of the in the geofeeds should be empty, and then the geolocation database providers can then take that into account. They then might have a specific flag in their in their database showing, okay, it's the last location that we've seen was this one, but it's currently the person responsible for this prefix tells me, okay, there shouldn't be any location at all, and then the people using the data could then make the determination: do they want to have the last location that was seen for this, that was determined for this prefix, or do they want to say, okay, it doesn't have any location? Because some people always need a location, right? It's a customer need. Sometimes they are not happy if sometimes they have there's no location for this. What does that mean? How can that be possible, right? So that's I guess the conflicting interests, I guess, of the stakeholders.
But it's also I think the question on how frequently the geolocation database is updated. It's all about a matter of execution speed.
Yes, that's correct. That's correct.
Mm-hmm.
So there's a website, geolocatemuch.com, which basically tells you, so for geofeeds, how long does it take for different geolocation database providers to update. So you can see for yourself how frequent geolocation database providers update new information in geofeeds. And yeah.
Awesome. What about the countries that, for example, the internet is down and you are not able to probe those locations? We have a very good example about one of the Middle East countries right now.
Yeah, that's I guess a challenge for everyone who runs. I mean, it's obviously very bad for people in those specific regions, right? Not only because they don't have access to the internet, but for all other sorts of things that are going on. But it's obviously also a big problem for people relying on internet measurements who then cannot have challenges running them because traffic is dropped at the entry point into that country. And if we have points of presence of our Probenet in those specific countries, we can only measure them within that country and not outside anymore. So that kind of restricts the measurements to some degree, but we can still run those measurements within those specific countries. So it still allows us to do those kinds of validations that I've talked about earlier, only with, I guess, with a more limited scope in a sense. So yeah, it's a challenge, but yeah, we're doing our best to still provide useful information for even for those special cases that are ongoing.
Interesting. So what could cause, this is a very specific question, but what could cause the accuracy drift of the data? Not even the geolocation, but any other type of information that is in location.
By accuracy drift, you mean that's old data is not accurate anymore?
No, yeah, exactly. Yeah.
So there are different things that can be causing changes in the data. I think we see more than 10% monthly city location changes in the geolocation database. So 10% of all of the IP addresses in those in that database are changing every month, right? So and that's already tells you kind of the scope. So it's not a small percentage of IP address that is changing, but it's a large one. And I mean, IP leasing, I guess, is one of the things that is happening, right? So if somebody leases a prefix on a leasing provider platform, and then they're using it somewhere, and then they give it back, and then somebody else leases it, use it somewhere, that obviously changes the location. But also any network that is kind of a multinational network that is using the IP addresses in location A and then decides, okay, now we have more demand in location B. They're shifting the whole /24 or so to location B to cope with the demand and spin up more servers in that location. So all of these kind of things just make the internet kind of a dynamic and ever-evolving organism. And that's what also makes it challenging then to solve all of those internet data problems.
Coming back to, because we haven't touched much about very stable networks, like, for example, telcos, ISPs. So what reliability expectations operators should have from the geolocation perspective?
So that, I guess, depends on what they are using the geolocation information for. So if they internally know that the geolocation of their IP or their prefixes is not changing, then that will be then reflected in geolocation databases as well. And we do also see these changes in ISPs. If an ISP is building new fiber deployments in a certain regions, then and they're running ad campaigns to get more people on board. That obviously will lead to more demand in those regions, and then they might be shifting resources, IP resources, geographically as well. But you're right. I think overall, if you look at let's say larger, very established ISPs, there is less churn, less changes in those networks compared to maybe let's say content delivery networks or other kinds of network where by nature they're more dynamic in terms of growth and content that they're providing.
So what's the biggest challenge you have in today's internet from the internet measurement perspectives?
Yeah, I mean, there are many challenges. I think we went through a bunch of the challenges.
We still have one.
I know what's coming. Is it IPv6?
Yeah. But I would also would love to touch a little bit about the domain names, because I think that they are very much related to the IP addresses. But anyway, yeah. So what are the biggest challenges you see in today's internet for making the things accurate?
I think if I would basically boil it down to a single thing, it's just the dynamic nature of the internet, right? So it's a moving target, right? You can't say, okay, we just have 10% more to go and then we are there, because it's at that point it's already moved away again, right? So it's dynamic, it's constantly changing, and you know that obviously as well, right? So
sure.
That's the
we are part of movement.
You're part of the movement, right? You're part of kind of moving it always a little bit, and that makes it challenging, right? If it wouldn't be changing, then you could just kind of very incrementally say, okay, well, now we solved this, let's solve the next. We solved it. That's next solved it. But that's kind of the biggest challenge, is to keep up or exceed the dynamicity of the internet.
Right. So let's talk about IPv6. Now, IPv6 is a different beast comparing to IPv4, but I should start from the question, not about, is IPv6 so important, but I would ask you, how relevant is IPv6 in today's internet?
It depends. It depends on who you're asking or who you are, right? So I would say overall, it's the relevance is just ever increasing, right? If you ask maybe, and I think this boils down to kind of a chicken and egg problem always, right? You see, okay, website operators or server operators are not deploying IPv6 because there are not enough clients, and then ISPs with clients are not deploying IPv6 because there are not enough websites supporting IPv6. So you always have this chicken and egg problem with IPv6. But we do see constantly increasing deployment of IPv6, and I think Google might be serving now half or so of all of its requests are coming from over IPv6, right? So from that perspective, it's already very relevant and it's there, right?
But there is one thing to remember, and it's I would say that this is a game changer line. Around, if I'm not mistaken, but around 70 or 80% of all the Google traffic comes from bots. So
I think they filter those out in the statistics. I think so. I mean, maybe they're doing their best, right? So that's just one of the statistics. I think we can look at many of the other statistics, but we do have customers asking us also, okay, are we prepared for IPv6? They are seeing an increase in traffic over IPv6. Are we able to cope with that? And do we have that covered, right? So are we ready?
Can you?
We can. Yes, we can. Yes, we can.
Okay, so do you have all the information about IPv6? Every single IP address?
So that's, as you well know, and many in the audience also know, the IPv6 address space is just very, very large, right? So
Zillions.
There are more IPv6 addresses than there are, I guess, atoms in the universe or something. Like it's incredibly large, right? So that's at least the theoretical addresses. So there is no way to conduct measurements towards all of those theoretically possible addresses. We do conduct measurements to a very large number, more than IPv4 measurements actually, towards IPv6, and that's to all of the addresses that we know or we've found somewhere or we've encountered during our measurements. For example, if we run trace routes. All of those kind of IPv6 addresses, we basically collect and we create like a very large target list, and then we conduct the measurements towards those IPv6 addresses as well. Yeah.
Interesting. So as I mentioned, during that conference, we were in Madrid. Many were proud how many of IPv6 they were able to scan, and I thought that, okay, this is a big thing among the internet researchers.
It is. Yes. Yes. And I think sometimes research is a bit decoupled, or academic research is decoupled from kind of what businesses are interested in.
Yeah.
But I think
in most of the time, actually.
Maybe most of the time, right? So I mean, I was in academia, and I thought different things of how the business world works, and then I joined IPinfo and saw, okay, it's a bit different than what you think as an academician, as an academic. Sorry. So yeah, there is definitely some discrepancies, between what academia thinks is important and what businesses think is important. But what I think is similar is that there is a movement towards IPv6. The importance of IPv6 is increasing in academia, and it's also increasing in the corporate world as well, right? The rate might be different. The share of interest in the corporate world might be lower compared to academia, but overall, I think people are realizing that IPv6 is something that's coming. It's not going away. IP leasing providers might be doing their best, but they can't stop it.
Actually, no. You know what? We actually give IPv6 for free. We give IPv6 for free. Guys, play with it. Enjoy the experiments. If you want to use it on your, business critical infrastructure, use it. That's fine, And IPv6 is nice, but it's just I thought, I think that people had too many expectations within very short time. That's what happened. But anyway, yeah. Now, since our time is running out, I would like to also emphasize a little bit about the domain names, because I think that it's also a very critical element within the whole ecosystem. And tell me more about the domain names. What do you observe around them?
You have any specific question that you're
So
interested in with
specific
regards
questions
to domain names?
yeah. So for us, what we actually see that you can spot very new domain names, and then actually you get your assumptions. What's gonna be the result of those domain names, right? Again, when we touch about the RDNS records, and I think this is very, very big data feed for you guys, the actual RDNS, and you also can spot, the things and make your assumptions on what's gonna happen. The IP address is having some random domain names, set on RDNS. So, my question to you is, what data do you observe from the domain perspectives, and what the community should be cautious about, seeing newly registered domain names on. And I know the answer, but I would like that you as a
That
head
I
of
come up with the
research
answer.
would tell this, and many more things,
Yeah,
what
yeah.
they should be aware of.
Yeah. So as you said, domain names are a very important part of the ecosystem, and we use domain names in various different ways. You've already touched upon, or we've already touched upon reverse DNS names, which then can contain location information, and then you can extract those and say, okay, we add that as another hint. Obviously, those are not necessarily always accurate, right? So you can have location information in reverse DNS names, which is outdated, not updated anymore, and then it points to a location that that IP address and the domain name were used before, but then maybe companies have merged, companies got acquired or so, and that obviously leads to inaccurate or out of date information in those reverse DNS names. What you're probably alluding to is that some of the domain names, there are different kind of threats when it comes to the domain names, right? So we can have like typosquatting domains. We can have like domains which are generated by algorithms, and they're basically cycled through for botnet purposes or so. So there are a lot of different kind of security relevant aspects to domain names that we see. And that's definitely that all of that data we basically ingested and use it for our different products. We don't have a security product, so we're not kind of ranking domain names based on their fraud potential or so, right? But that would probably be something that you could do by looking at the domain name. Is it very similar to, is it like google.com but misspelled, or does it have some like weird diacritics or so, so that people get lured on these phishing sites or so, and then enter their credentials there, and then they're stolen by somebody else. So there are a lot of
I was amazed about how easy you can make Microsoft from the first letter R and then the next letter N. It's crazy, and those mistypes leads to a huge phishing scams and whatnot.
Yeah, and I guess also it's difficult to spot this even as an expert, right? So it's not that people who get on those phishing sites and enter their credentials that those don't have a clue about the internet. It's also like experts such as us who could get tricked by these phishing websites. So it's I think there are different companies are doing various things to detect those and also try to protect users or web browsers are also doing that, right? So they have like a list of domain names that are as flagged as malicious, and then you get a warning or so if you're visiting that website. But yeah, I guess it's always a moving target, right? So it's as a theme maybe for this kind of webinar today, it's a moving target. So everything is evolving. The bad people are evolving, and then the good people have to catch up. So it's a cat and mouse game.
I think that back in early 2000s, the internet was such a quiet place. Even back in 90s, but I think that, from, where the internet is going, I think that we definitely will see more dynamic moving parts around us. Looking at the edge compute, CDNs, the hyperscalers, different, all sort of new technologies that actually can, make packets fly faster and whatnot, right? So I think we definitely, and of course, another thing is, not always CJ is the answer, So it's also the thing where we would see even many users, perhaps, even not knowing this, but we gonna sit on a single IP address, I had actually a funny story where they said that there is a country in Asia, I think Maldives, and what's Maldives capital? You don't know, right? Anyway, the capital of Maldives has the internet where they actually routed 64,000 people on one IP address.
Wow.
So
you could call it efficient, I guess.
Yeah, so how can you actually extract the correct geolocation of this?
That's I think one of the challenges, right? So multiple people behind an IP address, so you can maybe determine, okay, it's that specific region or that country, but then if you have multiple cities, people from multiple cities using a single IP address, then it's obviously doesn't make sense to have like a single city location assigned to it. So those are the kinds of challenges that IP geolocation providers are constantly working on solving.
It's really great stuff, and you do tremendous job on making sure that the internet is accurate. I'm not sure. Do we have any questions from the audience today? If not, then actually I would like to thank you, Oliver, for very great conversation. And I think it's really amazing to work with you guys, building with accuracy and dynamic environment, but keeping accurate. So, and I think that probably it's not our last webinar, but I guess at the same time, for now, let's work on the things that we have to do, right?
Thanks a lot for the invitation of the webinar. It was a lot of fun discussing all of those topics with you, and hope that the audience found it interesting and insightful as well.
Absolutely. I'm sure about that. Thank you very much, Oliver. Thanks a lot, community. Stay with us for the next webinar, which is happening in February, and the topic will gonna be announced. We're gonna have a big topic of this year within the infrastructure, within the AI, within the networks, and we're gonna have many cool speakers. years ahead. Thanks a lot. Thanks for the work.
Thank you.
Bye.
Bye-bye.